All right, you guys, we are looking at dividing radical expressions in this video. So radicals are not allowed in the denominator, so we have to rationalize. All right, so let's look at this first example. In this first example, we have the square root of 3/7. Now, we can rewrite this so the square root is in the numerator and in our denominator. And we see that we can't simplify the square root of 7. So what we have to do is we have to multiply the numerator and the denominator by something so we no longer have a radical in our denominator. Since 7 is a prime number, we know that we need another 7 for the 7 to leave the radical, since our index here is a 2. So I'm going to multiply my numerator and my denominator by the square root of 7. This way, in my denominator, I now have the square root of 49, since I can multiply those two radicals since they have the same index, and I know the square root of 49 is just 7. And now I no longer have a radical in my denominator. In my numerator, though, I will get the square root of 21, and I know that doesn't break down since I just multiplied two prime numbers together. So my simplified answer is the square root of 21 over 7. And remember, I can't divide 21 by 7 since 21 is safe inside of that radical and the 7's not inside of it. In the second example, I'm going to first rewrite it. So both the numerator and my denominator have a square root. And now 11, that's another prime number. So for the 11 to leave the radical, it needs to leave in groups of 2. So I need another 11. I also have a variable, I have an x. And for the x to leave, it needs to be in a group of 2. So I also need an x. So I'm going to multiply my numerator and my denominator by the square root of 11x. And when I do that, in my numerator, I'll get the square root of 55x. And in my denominator, I'll get the square root of 121x squared, which I know simplifies to just 11x, because that's, after all, what I was trying to move out of the radical in the first place. Again, you're going to want to cancel out those x's because you see one in the numerator and one in the denominator. But remember, one's safe inside of that radical and the other one's outside, so they can't affect each other.
This is Miss Reese wishing you good luck on trying these two bottom problems. You're going to do great.
All right, now we're going to divide cube roots and fourth roots. So we need to think about what to multiply by when we rationalize. All right, so let's look at our first example. Again, we're not allowed to have radicals in our denominator, so we have to simplify this, or we have to rationalize it. We're looking and we see that our index in this case is a 3. So in order for anything underneath our radical to leave the radical, it needs to leave in groups of 3. We have two x's, since it's x squared, and we have one y. So I need one more x, and I need two more y's. So I'm going to multiply by the cubed root, because in order to multiply, you have to have the same index. And I'm going to have one more x to make 3 x's, and 2 more y's to make 3 y's. And what you multiply the denominator by, you do the same thing to the numerator. So the cubed root of x, y squared. When I multiply, in my numerator I'll have 3 on the outside times the cubed root of xy squared. And in my denominator, I now have 3 x's. So an x will come out, and I also have 3 y's. So a y will come out. And this is my final answer. Look at my second example. If you can simplify before you start to rationalize, that's always a good idea. So I see that in my numerator, I have the fourth root of 15, and in my denominator, I have the fourth root of 5y squared. If I rewrote this as one whole radical, it would be the fourth root of 15 divided by 5y squared. And I could simplify 15 over 5 and make this the fourth root of 10, of 3 over y squared. And then when I go to separate my radicals back to my numerator and my denominator, I now have the fourth root of 3 over the fourth root of y squared. I still have a radical in my denominator, which I'll have to get rid of by rationalizing. I have 2 y's, and in order to leave, I need a group of 4, so I need 2 more. So I'm going to multiply both my numerator and my denominator by the fourth root of y squared. So I'll have a total of 4 y's. So my final answer here, when I multiply, I'll get the fourth root of 3y squared over, and now that I have 4 y's, 2 here and 2 here, a y will come out.
Miss Reese coming at you again with 2 more problems to knock out of the park.
All right, in these last couple examples, we're going to look at dividing binomial radical expressions. So in these 2 cases, we'll need to use conjugates, and therefore we'll need to use double distribution. All right, so in this first example, I see I have a radical in my denominator. Now this square root of 5 minus 2, this expression, they're kind of together. So it's not like before where I just need one more 5 to come out, because if I multiplied by only the square root of 5, well, I would have to distribute it to each of these terms, and then I'd still have 2 square roots of 5 in my denominator, and it would not help me by simplifying that way. So instead, when you have a binomial in your denominator, we'll multiply by the conjugate. So if I have the square root of 5 minus 2, the conjugate of that's going to be the square root of 5 plus 2. And since I have to multiply the denominator by that, I'll have to multiply our numerator by that as well. And I'm throwing parentheses around here to remind me that I'm going to double distribute. Now in my numerator, I only have one term. So when I distribute the square root of 3 times the square root of 5, I'll get the square root of 15. And the square root of 3 times 2, I'll get plus 2 radical 3. In my denominator, since they are conjugates, I don't have to use FOIL. I get to cheat, and I can just say first times first and last times last. So when I do that, square root of 5 times square root of 5 is the square root of 25, or just 5. And negative 2 times 2 is negative 4. I can simplify this further. 5 minus 4 is just 1, and dividing by 1 is the same. So I have the square root of 15 plus 2 radical 3 as my final answer. Looking at my second example, I have a binomial in my numerator and a binomial in my denominator. I still only care about the radical in my denominator, so I'm going to multiply by the conjugate of my denominator. That's the one that matters. So our conjugate here will be 5 minus the square root of 24. And again, top and bottom. So in the numerator, since it's a binomial, I'll have to use double distribution. So 3 times 5 is 15. 3 times radical 6, I get 3 radical 6. Square root of 6 times 5, I get 5 radical 6. And square root of 6 times the square root of 6 is the square root of 36, which is just 6. I'm going to continue to simplify in my numerator before I move to my denominator. And I get, combining my first and my last term, I get 21. And combining my middle terms, I get a positive 8 radical 6. This is all over. And my denominator, again, since they are conjugates, instead of doing FOIL, I'm just going to say first times first, get 25, and last times last, I get minus 24. And 25 minus 24 is just 1. and dividing by 1 doesn't change anything. So here is my answer.
This is Miss Reese with your last two. Would you like me to serve those with bacon and eggs? Because I have a feeling you'll be eating them for breakfast.